The eastern flank of Poland entered a new operational phase, a phase where the frontier with Kaliningrad stopped functioning as a political boundary and became a continuous military contour shaped for long-term deployment. The sector, once defined by forests, marsh belts, and scattered transport nodes, turned into a zone where engineering battalions, observation assets, and rapid reaction elements formed a unified defensive architecture. The terrain created a natural corridor stretching from the northern coastal strip toward the deeper interior of Poland, a corridor whose control determines the stability of the entire northeastern front. The decision to fortify this line assigned the region the status of a primary direction, where every ridge, drainage channel, and access road receives operational meaning. The new configuration transforms the border into a structured defensive belt, capable of managing movement, disrupting hostile infiltration, and supporting forward-facing fire systems. Along the contact zone with Kaliningrad, the landscape consists of alternating forest masses, low marshland, and narrow elevated sections that form natural choke points. These features enable the installation of layered obstacles and create conditions for establishing fields of observation that stretch across extended distances. The area contains railway spurs, maintenance yards, and logistical lanes feeding the central and northern districts of Poland. These routes form the backbone of national mobility, which makes them critical for the deployment of heavy engineering formations and armored elements responsible for anchoring the new fortified sector. The geography allows the Polish command to integrate surveillance towers, acoustic arrays, and thermal optical systems, consolidating them into a single reconnaissance grid aligned toward the Russian exclave. The emerging structure resembles a modernized variant of a static frontier defense line, but with the mobility and precision typical of contemporary NATO doctrine. The operational value of this corridor increased after repeated hybrid pressures attributed to Russia, pressures that affected migration routes, information channels, and border activity. These tendencies forced the Polish command to shift from reactive patrolling to permanent border militarization. Engineering brigades began mapping soil density, water levels, and vegetation corridors to prepare sites for trench networks, anti-vehicle berms, and hardened firing positions. The combination of natural obstacles and artificial barriers created an environment where any hostile probing action would be detected early and countered through maneuver groups stationed along pre-designated routes. This transformation effectively turned the region into an elongated operational barrier, capable of absorbing the initial phase of an incursion and imposing heavy constraints on adversary mobility. The presence of NATO assets added a second dimension to the geography. Air defense detachments operating Western systems received deployment corridors along the elevated ridges and cleared forest gaps, enabling overlapping engagement zones aimed directly toward the Kaliningrad airspace. Infrastructure for hosting Allied units appeared near existing logistics hubs, reinforcing the multinational character of the defensive effort. The combined effect redefined the frontier as a high-density line, where reconnaissance, engineering, and maneuver elements operate under a unified command structure. Poland effectively positioned the corridor as a forward containment zone, where control of terrain and communications holds greater weight than raw troop concentration. This created conditions for a long-term buildup, foreshadowing a large-scale defensive operation conducted across a continuous reinforced perimeter. The planning phase of the Polish operation unfolded as a layered engineering campaign, a campaign where reconnaissance, terrain analysis, and force distribution became the foundation of the emerging fortified belt. The concept relied on three structural pillars: a continuous engineering line, a mobile maneuver reserve, and an integrated reconnaissance grid. Each element supported the others, forming a system designed to absorb pressure along the entire frontier with Kaliningrad. The Polish command defined the task as building a persistent barrier capable of disrupting any hostile momentum before it reached transportation corridors leading toward the central regions of the country. To achieve this, engineering battalions conducted soil penetration studies, stability testing on marsh-adjacent ridges, and mapping of water-saturated surfaces to identify zones suitable for heavy machinery and areas requiring reinforcement. Every trench line, berm, and anti-vehicle barrier was calculated in relation to the terrain's natural geometry rather than administrative boundaries. Forward engineering companies moved into pre-designated positions under the cover of forestry belts and elevated ground, establishing initial excavation lines. Behind them, logistical elements created supply lanes for concrete, steel, prefabricated bunker modules and multi-layer fencing systems. The construction resembled an unfolding operation rather than a civilian project. Machinery arrived in columns, escorted by patrol units and drone overwatch that scanned the treetops and marsh routes for signs of movement. The concept demanded uninterrupted tempo, which required establishing rear distribution hubs where repair teams, fuel carriers, and bridging specialists could sustain the momentum of the build. These hubs integrated into existing military infrastructure, converting previously quiet maintenance areas into active operational nodes feeding the frontline engineering effort. The reconnaissance grid was the second critical element. Poland activated aerial reconnaissance platforms, rotary wing units, and long-endurance drones that created a permanent observation canopy over the border strip. Their task was to monitor vehicle tracks, heat signatures, and movement patterns emerging from the Kaliningrad direction. Thermal optical stations were installed along elevated outcrops to feed data directly to command posts that coordinated engineering maneuvers on the ground. This system enabled rapid adaptation whenever new gaps or vulnerabilities were detected. Polish planners incorporated satellite-based contour mapping, enabling precise alignment of obstacle belts with natural choke points, areas where even minor disruptions could immobilize an approaching armored group. This continuous data flow shaped the operational tempo, ensuring that engineering lines expanded without leaving exploitable seams. Maneuver reserves formed the third layer of the concept. These units remained stationed at variable depth behind the construction axis, occupying positions near road junctions, dry ground plateaus, and transport yards. Their mission was not to engage in static defense but to secure the engineering battalions during the build and respond to any attempts by an adversary to conduct reconnaissance in force. The reserves included mechanized elements, drone intercept teams, and mobile anti-armor detachments capable of moving along pre-cleared routes. Their integration ensured that the construction line did not operate as a passive barrier, but as a forward operational shield supported by rapid response components. The Polish command viewed the entire operation as a long-term fortification of the northeastern strategic direction. Planners divided the corridor into sectors, each assigned to a dedicated engineering group with clear responsibilities: excavation, reinforcement, obstacle layering, sensor installation, and logistical sustainment. Coordination between the sectors occurred through hardened command nodes placed at intervals along key access roads. These nodes controlled the distribution of materials, the deployment of heavy equipment, and the rotation of engineering personnel. The goal was to maintain alignment across the entire length of the border, preventing fragmentation and ensuring that every segment advanced at a synchronized pace. The concept prioritized depth, redundancy, and continuous coverage, qualities that define modern defensive infrastructure operating under NATO protocols. As the planning matured, Poland incorporated Allied assets into the operation. United States air defense contingents and European surveillance detachments were assigned observation arcs and deployment guidelines, ensuring their integration into the final defensive layout. This elevated the fortified belt from a national barrier to a multinational defensive structure, where shared data streams and combined logistics enhanced resilience. The presence of Allied personnel influenced positioning decisions for radar arrays, drone intercept stations, and hardened shelters, ensuring that the barrier operated as a complete, networked defense architecture rather than a collection of isolated installations. By the time the planning phase reached full operational readiness, the structure of the operation had acquired clarity: engineering forces would move first, maneuver reserves would secure their advance, and surveillance assets would maintain uninterrupted awareness of the Kaliningrad axis. This alignment prepared the corridor for the transition to the execution phase, where the theoretical design of the fortified belt would transform into a continuous physical reality stretching across the northeastern frontier. The initial phase of the operation unfolded as a coordinated advance of engineering columns along the frontier with Kaliningrad, an advance that resembled the opening stage of a deliberate positional deployment rather than a civil construction effort. The first echelon consisted of tracked excavators, trenchers, and armored utility vehicles moving under the protection of reconnaissance drones that formed a permanent canopy above the tree line. Their movement created a visible arc along the border, marking the contours of the future fortified belt. As the machines reached their designated positions, engineer crews began cutting into the soil, shaping the first continuous trench systems intended to anchor the defensive layout. These trenches aligned with natural folds of the terrain, forming curved segments that absorbed ground elevation and used forest ridges as concealed reinforcement zones. Behind the leading excavators moved the second echelon, transporters carrying concrete barriers, anti-vehicle blocks, and prefabricated bunker frames. Each delivery route was secured by patrol elements that monitored forest corridors and marsh paths for signs of hostile reconnaissance. The placement of barriers followed a predetermined geometry, linear segments oriented toward likely approach avenues, interlocked with diagonal sections designed to break the momentum of any tracked or wheeled formation. Every segment of the barrier network strengthened the emerging operational line, converting the previously passive frontier into a hardened defensive contour. As materials accumulated on site, crane units began lowering reinforced structures into excavation pits, forming the first hardened nodes that would later serve as observation posts and firing positions. Drone activity intensified as the initial barrier took shape. Overhead reconnaissance platforms swept arcs across the Kaliningrad direction, identifying ground disturbances, vehicle signatures, and thermal anomalies that could signal early attempts to probe the developing structure. Data streamed back to tactical command posts, where analysts compared movement patterns with historical baselines. This constant monitoring ensured that the engineering effort advanced without exposure to surprise incursions. Sensor teams installed seismic detectors and thermal arrays along the emerging obstacle line, embedding them in concealed positions within the forest understory. These systems expanded the observation grid, giving Poland an extended early warning capability across terrain that traditionally favored covert infiltration. The excavation zones expanded outward as crews connected individual segments into a continuous defensive ribbon. The scale of activity altered the landscape. Temporary access roads appeared across marsh fringes, allowing heavy machinery to maneuver and creating controlled corridors for logistical flow. Supply units delivered steel mesh, concertina coils and layering materials required for multi-tier barrier construction. Parallel to these efforts, Polish engineering brigades constructed reinforced shelters at key positions along the belt. These shelters were intended to protect command personnel, sensor operators, and rapid response detachments during elevated alert conditions. Their design incorporated blast-resistant materials, internal communication nodes, and concealed exit routes, enabling swift movement into pre-surveyed engagement positions. Each shelter functioned as an embedded element within the broader defensive lattice, linking maneuver units with sensor networks and engineering echelons. As the fortified belt grew in length and density, its operational effect became evident across the border region. Traditional infiltration routes through forest passages and marsh crossings were blocked by multi-layer obstacles, forcing any hostile movement into predictable corridors easily monitored by the surveillance grid. Marsh-adjacent ridges previously offering cover for movement were now reinforced with overlapping sensor fields, eliminating natural blind zones. The defense corridor shaped the geography into a controlled environment where Poland itself dictated the terms of mobility. NATO support units intensified their coordination with Polish command. Air defense detachments aligned their deployment sites with the newly built observation towers, creating integrated engagement zones capable of covering long stretches of the frontier. Allied reconnaissance platforms synchronized flights with Polish drone operators, producing a unified aerial picture of the Kaliningrad approaches. This multinational integration ensured that the fortified belt operated as a coherent network, not as a collection of isolated national segments. The presence of Allied assets amplified the deterrent effect of the construction, projecting operational capacity far beyond the physical barrier itself. By the time the fortified belt extended across the majority of the designated sectors, the border with Kaliningrad adopted the characteristics of a fully formed operational zone. The combination of trenches, reinforced obstacles, maneuver-ready reserves, surveillance grids and multinational support elements created a defensive architecture with significant depth and persistence. The frontier became a controlled battle space where observation, mobility and firepower were integrated into a single, cohesive system. The operation progressed steadily, preparing the region for the decisive structural consolidation that would define the next phase of the build. The operational peak emerged when the fortified belt reached a degree of depth and structural density that altered the balance along the entire frontier with Kaliningrad. At this stage, engineering battalions, maneuver reserves, and surveillance elements functioned as a unified system shaped for sustained defensive readiness. The obstacle network had expanded into a multi-tier architecture composed of primary trenches, secondary excavation lines, reinforced barriers, concealed firing positions and sensor clusters distributed across forest ridges, marsh plateaus and elevated ground corridors. This configuration created a continuous defensive fabric capable of absorbing pressure, channeling movement and isolating any hostile element attempting to breach the perimeter. The geography itself became a controlled instrument of defense, shaped through engineering precision and persistent reconnaissance. The consolidation phase introduced hardened command nodes directly embedded within the fortified belt. These nodes incorporated reinforced structures, internal communication arrays, protected observation chambers and concealed ingress routes, enabling rapid coordination between engineering echelons and maneuver detachments. Each node functioned as a local control hub where reconnaissance data, sensor output, and mobility plans converged. Their positioning along elevated terrain ensured uninterrupted command continuity across the entire sector. The presence of these nodes transformed the barrier from a linear obstacle into a dynamic operational command network, capable of directing responses, redistributing forces, and managing multi-layer defensive tasks. Maneuver reserves reached peak readiness during this phase. Armored groups occupied predetermined staging areas along cleared forest corridors, maintaining mobility toward any segment requiring reinforcement. Drone intercept teams expanded their patrol arcs, securing the airspace above the belt and denying reconnaissance access to any approaching aerial platform. These teams operated in coordination with thermal optical towers that scanned the Kaliningrad direction, identifying airborne movement and directing countermeasure units accordingly. The alignment of ground maneuver elements with aerial surveillance produced a synchronized security envelope covering the entire corridor. Engineering brigades reinforced the main trench lines with additional layers of structural support. Blast-absorbing berms were elevated, concrete modules were embedded deeper into the soil, and secondary access routes were fortified to ensure reliable movement for supply and repair teams. These improvements enabled the barrier to withstand sustained pressure without degradation of its core defensive properties. The multi-layer trench network provided depth, redundancy, and operational persistence, turning the frontier into a terrain where every advance route would encounter successive obstacles aligned with overlapping observation fields. This created a geometry specifically engineered to break momentum and restrict maneuver freedom for any hostile armored group. NATO support reached its highest level of integration during the operational peak. Allied air defense detachments synchronized engagement zones with Polish observation towers, forming extended arcs that projected defensive coverage deep toward the approaches facing Kaliningrad. Surveillance aircraft linked their data streams with ground-based sensor grids, generating a unified operational picture shared across multiple command posts. This multinational fusion elevated the fortified belt into a broader collective defense zone, extending the operational effect of the barrier beyond national boundaries. The synchronization of Allied and Polish assets strengthened the deterrent posture and emphasized the strategic weight of the construction. The operational peak also marked the moment when the barrier's structural density reached a threshold where traditional infiltration routes ceased to function. Forest passages, marsh crossings and concealed approach lanes previously used for reconnaissance enforce were now blocked by multi-layer obstacles and continuous sensor coverage. Thermal arrays overlapped across every likely movement channel, ensuring early detection of ground signatures. Seismic detectors monitored the deeper marshland, capturing vibrations produced by any movement across unstable terrain. The frontier became a controlled space where hostile maneuvering was stripped of unpredictability, forcing any advance into monitored corridors shaped by the fortified belt. During this stage, Poland initiated final synchronization rehearsals. Engineering echelons conducted timed transitions from construction to defensive posture, maneuver units traced their flanking routes across variable terrain, and sensor crews aligned their detection thresholds with the operational requirements of the command nodes. These rehearsals ensured that the fortified belt could shift instantly from construction mode to active defensive readiness. The entire corridor functioned as a single, responsive organism where observation, mobility and structural resilience operated in coordination. By the end of the operational peak, the fortified belt achieved full consolidation across the designated frontier. It no longer resembled a construction effort, it functioned as a hardened, multi-layer defensive system integrated with multinational support, surveillance dominance and maneuver-ready reserves. The region adopted the characteristics of a stabilized operational zone where control of terrain, communication routes and approach channels shifted decisively toward the Polish command. The fortified belt established a new strategic reality along the border with Kaliningrad, preparing the sector for the transition into the final stabilization phase. The final stage of the operation began when the fortified belt transitioned from an expanding construction axis into a stabilized defensive zone operating under permanent readiness protocols. This stage focused on sealing residual gaps, consolidating depth positions and integrating the barrier into long-term operational routines. Engineering echelons shifted from large-scale excavation to precision reinforcement, strengthening trench walls, deepening anti-vehicle pits and embedding additional structural layers beneath the primary obstacles. These actions produced a dense network of interlocking fortifications stretching across the frontier with Kaliningrad, forming a spatial configuration where movement, observation and response were fully coordinated. The landscape adopted the characteristics of a hardened defense corridor engineered for extended endurance. Sensor crews entered a systematic calibration phase. Thermal arrays, seismic detectors and ground surveillance radars underwent synchronization cycles to ensure uniform sensitivity across the belt. Calibration teams adjusted detection thresholds to reduce false signatures in forest corridors and enhance reliability in marsh-adjacent zones where soil density affected vibration patterns. Observation towers aligned their optical baselines with long-range aerial platforms, merging ground-level detection with high-altitude reconnaissance coverage. This integration created a multi-layer surveillance canopy forming a continuous observation shield over the entire frontier. With every system synchronized, the belt achieved a state where no ground or aerial movement along the approach axis could occur without registration across the sensor grid. As stabilization continued, maneuver reserves adjusted their posture. Mechanized groups redistributed across secondary ridgelines, adopting depth positions designed for rapid deployment. These positions offered clear lines of movement toward any segment requiring reinforcement, while maintaining concealment within forested strips. Drone intercept elements extended patrol schedules, ensuring uninterrupted protection of the airspace above the barrier. Their presence maintained the integrity of the operational envelope and protected the layout of the fortifications from hostile mapping attempts originating across the Kaliningrad direction. These units rehearsed rapid convergence maneuvers, tracing pre-planned arcs that ensured immediate response to any detected shift along the border environment. NATO elements integrated their stabilization procedures with the Polish command. Air defense detachments repositioned launch platforms to align with the finalized observation towers, establishing reinforced engagement zones capable of covering wide arcs along the frontier. Allied reconnaissance flights synchronized their surveillance patterns with the ground sensor grid, generating a unified operating picture updated in real time. This alignment strengthened the defensive posture and transformed the fortified belt into a multinational collective security perimeter, capable of sustained operation under varied strategic conditions. The integration also ensured that any pressure emerging from the Kaliningrad region would be assessed, tracked, and countered within a unified operational framework. Engineering brigades completed the installation of hardened shelters and communication nodes spaced across the depth of the corridor. Each shelter provided protected operating space for command personnel, sensor operators, and rapid reaction teams. These structures incorporated internal blast channels, concealed corridors, and reinforced foundations designed to survive significant kinetic pressure. The distribution of these shelters ensured continuity of command, even in conditions where outer layers of the barrier faced concentrated impact. Their presence consolidated the belt into a continuous defensive lattice, where command, maneuver, and observation existed as interdependent components. The final stabilization phase also introduced long-term sustainment protocols. Maintenance teams began periodic inspection cycles, repairing erosion damage along trench lines, reinforcing drainage systems to prevent flooding and replacing barrier segments subjected to environmental wear. These cycles ensured that the fortified belt would retain structural integrity across seasons, maintaining operational readiness without degradation. Supply depots positioned at depth stocked essential materials, fuel reserves, and replacement modules for sensors, ensuring immediate availability during elevated alert conditions. The sustainment network became a permanent component of the defensive infrastructure, supporting ongoing readiness across all sectors. As the barrier solidified, the frontier adopted a new operational rhythm. Patrol elements moved along designated observation routes, maintaining constant oversight of forest corridors, marsh edges, and elevated ground segments. Drone units executed layered patrol patterns above the belt, while sensor crews monitored real-time feeds across multiple channels. Command posts processed the continuous influx of reconnaissance data, updating sector readiness and coordinating the posture of maneuver reserves. This rhythm embedded the defensive architecture into daily operational practice, converting the fortified belt into a permanent fixture of the northeastern security environment. The final phase concluded when the frontier reached full structural and operational cohesion. The fortified belt stood as a hardened, interconnected system of trenches, barriers, sensors, maneuver elements, and multinational support nodes. The entire sector operated as a stabilized operational zone, shaped for long-term endurance and capable of responding to any emergent threat originating from the Kaliningrad direction. With structural consolidation complete, the operation prepared to transition into the analytical stage where strategic implications and long-term effects would be assessed. The completion of the fortified belt along the frontier with Kaliningrad produced strategic consequences that reshaped the entire security architecture of the northeastern flank. The region transitioned from a vulnerable border strip into a hardened operational barrier, altering how mobility, reconnaissance, and force projection function across the corridor. The newly established structure integrated physical obstacles, deep sensor coverage, maneuver-ready reserves, and multinational support into a single defensive system. This transformation changed the strategic geometry of the area, creating a depth-oriented environment where each segment of terrain carried operational weight. The fortified belt imposed new limitations on any movement emerging from the Russian exclave, redefining the role of Kaliningrad within the broader regional balance. The fortified corridor introduced a long-term denial effect across natural and artificial approach routes. Forest passages, marsh channels, and elevated ridgelines once suitable for covert maneuvering became saturated with overlapping observation fields. Thermal arrays, seismic grids, and ground-based optical networks eliminated blind zones, forcing any hostile presence into predictable, monitored channels. This changed the operational logic of the region, making rapid thrusts or reconnaissance in force significantly more difficult to execute. The fortified belt imposed a structural constraint on adversary plans, transforming the frontier into an area where early detection and immediate counteraction were inherent to the terrain itself. NATO integration elevated the defensive effect of the barrier. Allied air defense formations synchronized their operational cycles with the observation towers installed along the belt, projecting wide engagement arcs over the border zone. Reconnaissance platforms operated in alignment with Polish surveillance, generating a unified operational picture that enabled real-time monitoring of the approaches facing Kaliningrad. This multinational coordination expanded the deterrent value of the barrier from a national undertaking into a collective defense position, reinforcing the alliance's posture across the northeastern flank. The presence of Allied systems in close proximity to the Russian exclave introduced a strategic reality where Western defense assets operated directly at the edge of the contested region. The fortified belt also restructured the logistics architecture of the surrounding territory. Supply hubs, maintenance sites, and command nodes formed a network distributed across the depth of the corridor. These nodes supported not only defensive operations but also long-term stability, ensuring that reserves, fuel, materials, and sensor components remained available without reliance on distant routes. The logistical framework strengthened regional resilience and promoted sustained readiness across the entire perimeter. This integration of mobility, supply, and command nodes turned the frontier into a self-sufficient defensive sector capable of maintaining endurance over extended periods. From a strategic standpoint, the fortified belt introduced a shift in influence across the region. The construction demonstrated that pressure from the Kaliningrad direction no longer produced destabilizing effects. Instead, it triggered the consolidation of a hardened security perimeter aligned with NATO doctrine. The barrier signified that territorial pressure resulted not in retreat or caution but in the physical expansion of defensive infrastructure at the very edge of the Russian exclave. This outcome reversed the direction of deterrence, projecting operational capacity toward the contested zone and diminishing the ability of the opposing side to shape the environment. The operational system produced a persistent surveillance advantage. With multi-layer detection arrays, aerial reconnaissance integration and ground-based observation dominance, the fortified belt created continuous visibility over the region. This visibility translated into sustained control of situational awareness, ensuring that changes in troop movement, logistical activity, or reconnaissance patterns across Kaliningrad were registered across the network. The frontier transformed into a monitored corridor where uncertainty, traditionally the primary advantage of border operations, became structurally limited. The defensive belt established an environment where long-term intelligence superiority formed the basis of regional stability. The strategic effect of the operation extended beyond military considerations. The fortified belt signaled that the northeastern flank of Poland had transitioned into a zone where political and security decisions aligned with a long-term deterrent posture. The barrier shaped a landscape where pressure no longer created vulnerability but generated consolidation, coordination, and reinforcement. The presence of NATO infrastructure, combined with national engineering and reconnaissance capabilities, produced a symbolic and structural shift. The frontier with Kaliningrad became a demonstration of sustained defensive readiness, embedded directly against the Russian border. As the operation reached its conclusion, the fortified belt redefined the strategic balance across the region. The frontier evolved into a stabilized defensive corridor with depth, observation dominance, and multinational integration. This new configuration created a long-term environment where deterrence, control, and operational awareness formed the foundation of security. The fortified belt stood not as a temporary measure, but as a permanent structural presence shaping the future of the northeastern axis and setting the conditions for sustained stability along the contested border.